Hello everyone. So with this video, we are going to start the Python module section. Now, in the previous set of sections, we covered the basic of Python programming. Now we are going to move on to topic called Python modules, and this is the first video of the Python module video series. So before going on to anything, we have to identify what this module is, Python module. So what it mean by these modules. So simply, module is a library. So if you are familiar with libraries in other programming languages, C, C++, Java or anything, library or package kind of a thing. So module is in Python, module is similar to the libraries and packages in other programming languages, right? So when it comes to Python, we have three main types of modules available. The first one is inbuilt modules. That means with the Python installation, we are going to get some modules like math, OS, datetime, tickinter, email. Likewise, we have several, we have a set of modules that with the with the Python installation, those modules will be installed into our computer, then we can use it, right? Then the other type is our own modules. That means we can create our own modules, customized modules. So that's the second type. And the third type is third-party modules. That means the libraries or the modules that we can download from the internet and install separately in our computer and use, like OpenCV, NumPy, Matplotlib, Pandas, or like those kind of third-party modules are the third type, right? So we will first discuss about the first type of modules. Actually, what I want is to show you how to actually import a module into our computer and how to basically use it. So in order to do that, I will use math library. So I have selected math library. So math is a inbuilt module available with the Python installation, right? So how we are going to import a library into Python, that can be done using import command. So import math. So this is how you are going to import a module into the Python code. Now, after importing it, if you want to do something using that module, then always you have to call the functions, the constants and everything using the function name dot, right? So if we simply goes to the theory part of the modules, right? So module is simply, right, contains functions, classes, or variables, right? So that's what you call a module. So standard modules are also similar. So module is simply a set of organized, grouped set of codes, functions, classes, or variables, right? So in the math library, so we have several functions, inbuilt functions, and these are called methods. So here, for example, we have something called math, POW in math module, so which can be used to get the power. Now we can pass two parameters like 2 and 3, so it will give you the result like the power here. So simply it's giving like 2 into the power 3, right? Now don't worry why I'm talking about math library. No, we don't use math library in any of our advanced workshops like machine learning, deep learning, any workshop. We don't use the math library. What I want to show you is how to work with the general library. That's why I'm taking the math module. Otherwise, no use of math library for us, right? So we don't use any command in math library throughout our implementations in our advanced workshops, coming workshops, right? Anyway, what I want to show you now, the POW is a function or a module, we can say, which available inside the math. Now here you have to get the idea. If you want to call a function or anything inside the module, then you have to call it by the module name dot then the function name. So here you can use the it like this. So another function available sign, so that also math dot sign, right? And now you can see that we have several modules like Matplotlib, TensorFlow for neural networks, and we have lots of scikit-learn, OpenCV. We have lots of modules coming, third-party modules that we are going to learn in our advanced workshop. So now let's take Matplotlib. So that means like we have to always, when you are going to call a function, matplotlib dot matplotlib dot matplotlib dot, we have to call like that. No, the thing is we can import any library into a customized name. So as given here we are importing the math library as m. Now, if you import it like M, thereafter you can call it like not math dot, but you can call it like M dot, right? So you can give your customized short name to that module, right? So M dot power, M dot sign, likewise you can do that. And the other thing is, now this simply imports the whole math library, right? So then we call math dot whatever the module or the whatever the functions that we need. But what you can do is, without including the whole library, what you can do, you can simply select uh, whatever the functions required for this code, and we can implement those selected methods. We can include those selected functions only, right? So this is how we are going to do that. From math, import sign and cos. So we import the sign and cos functions. Those are the only functions that we need in this code, right? Assuming that we can import it like that. Then if you import individual functions, then no need to call it like math dot or m dot. So then you can call it directly through the function name, right? And also the other thing is, you can extend it, and the function you can give a customized name. So from math, we are importing POW and we import it as PW. So hereafter, we are not going to use it as POW, we use that PW, right? And if you want to, now I just got the math and you don't know about anything math. If you don't know anything about math and you don't know what are there in the math library, what you can do is you can get the content of the math library and you can get the help. Using the help function, what you can do is get the math library, import it, and then pass that library to the help function. So help function simply provides you in detail explanation about what this function does and what are the functions available. So you can see these are the functions. So you know a module can contain functions, right? Classes, variables, right? So this explains what are the functions available here. So you can see we have lots of functions, and the return values and what the function does, all the details are given here. And as well as at the end, I think this gives the constant values available in that function as well. So it has pi, tau, e, infinite, those kind of constant values are also shown. So you know, module can also contain constants as well, right? So those are the details you can see and you can get from the function, I mean from the help function, right? Okay, so you know what the module is. Now we discuss about inbuilt modules. So other than that, we have lots of inbuilt modules. So let me show where these modules are actually located, right? So let me go to the my Python, the Anaconda installation. Let me quickly show you the other window like this. Okay, so now I think this is where my Anaconda is installed, right? And in Anaconda you have a uh, folder called lib, right? So this lib contain everything. So you can see these are the inbuilt modules available for Python. So we will find math somewhere here, right? Math, yes, you can see the math library is also there, math module. And we have some JSON, test, tkinter. So tkinter is the graphical user interface, standard graphical user interface inbuilt library for Python. And we have, I think, date time. Yeah, date time. So date time is a library for time operations and get the time, current time and everything. And also we have the email library where we can use to send and receive emails, and OS library for operating system works, OS library. So all the inbuilt libraries are there. Now modules, so these are modules, and you can see module is simply a Python code, right? So if you open the OS code, I mean, probably we can't exactly get what's there, but if you use a notebook and open it, so this is simply a Python code, right? So module is a Python code. So these are the standard inbuilt Python modules, in the sense that with the Python installation, these are installed and we can use it for several applications, but I'm not going to go through each and every module, since this is not our focus. Our focus is something else, like we are going to move on to machine learning, deep learning in future, right? So what I wanted to show you in this example is that, okay, how to use this kind of a module and get these things done, and how to use the module, how to import it, and how to import functions separately and do these things, right? Okay, hope you understood. And then I'm going to now show you how we can create our own module, right? How we can create our own module. So I have a Python function here. So let me show you quickly. I have Python Python file simply called my calculator, right? So let me define the my calculator Python Jupyter notebook file. So it has several functions, and also a constant value is also there. I mean, variable is also there. So these functions are quite simple, like the addition, and it returns the addition, and this returns the subtraction, and this returns the power, right? And this returns the average function that you can remember. We did this using the variable length argument. So that function is there, the average function, find function. So this is the Python file and the Jupyter notebook file. So now what I'm going to do is I'm going to convert this to my own module. Now I told you that the second type is our own module. So I'm going to convert this as our own module. So nothing to do, simply just download it as a Python file, or you can implement this in a Python code, right? Okay, so then what you can do, you can, after downloading it, you can get it here. So I simply I will show you the location where my codes are currently saved, right? So yeah. Yeah, so this is where my code is currently. Now my calculator, so you can see, sorry, you can't see it here, right? So let me show you it as a yeah, like this. So my calculator, so I just download the pro Python file of that Jupyter notebook. So if I open it to confirm, yeah, so it contains this code, right? So it has like simple for functions and a variable, right? So now what I'm going to do, I'm going to go to a code, right? And I'm going to, let's say, yeah, testing my calculator, right? Okay, so what I have done here now, I think you will understand it if I show the both in the same window like this, right? So this is the my calculator Py, right? So can you see? Now this is just a Python code, right? So then I import it as my calculator as cal. So can you remember my math as m? So similarly, this is our own module, right? So see, then cal.add. So that calls this function. Cal.add, we pass values and you are going to get the return, and when the return is printed, you are going to see 12. And the subtraction and the average is also calculated like this, right? So this is actually how we are going to use our own function. I mean, own Python code as a module. So you can, I show this since I want to show you that, okay, so what you mean by a Python function, I mean a Python module is your simple Python code, right? So you can use it as a library or a module. Import my calculator as cal, right? Or else you can do is like this, you can import the individual functions as well, right? From my calculator, import average. So then you can directly call the average function like this, right? And you can get the average. So actually, a module is simple Python code, right? And you can load it as, and you can call the functions. Now, can you see the cal.value1? So cal.value1 simply prints this 1000 here, right? So module is simply a nothing, just a Python code, but you can import it to a another code, then you can use it as a library, or we can say a module, right? So this is simply what a user-defined module is, right? Okay, so now I hope that you understood what's the user-defined module. So let me go to the back again, right? Okay, so the third type of modules, right? So these are the modules that we are interested on this set of tutorial series. I mean, not this tutorial series, coming workshops as well. So let me show you that to you. And yeah, let me quickly get the video here. Right. So these are the actually the tools that we are using in this set of workshops, right? So we know that the programming language that we are using is Python, obvious, and the development environment we are using is Jupyter Notebook. And other than that, these are the third-party modules that we have to download externally and install in Python and run, right? So these are the uh, external modules, right? So you know what's the inbuilt modules, so the modules that install with the Python installation, and third, I mean, a customized module that the user, we can create our own modules. So those are the user-defined modules, and these are the third-party modules. And TensorFlow, Keras, OpenCV, Scikit-learn, Pandas, Matplotlib, NumPy. Now the important thing, these are called external modules, and these are like we can call them as library, but in Python these are called as modules. And when it comes to TensorFlow and Keras are the libraries or the modules that we are using for neural network implementations in our coming future workshops. And TensorFlow is provided by Google, and this is the best and mostly used, commonly used module available for Python for neural network implementation and provided by Google. And Keras is also something that we can use for neural network implementation together with TensorFlow. And OpenCV is the currently best open source module available for Python for image processing. Image processing applications, the best open source module, Open Computer Vision module. And Scikit-learn is again a product of Google, and Scikit-learn simply provide us the library, the best library for Python and for machine learning related tasks. So in our machine learning workshop, we will mainly focus on this Scikit-learn library and Scikit-learn module and implement our codes. And NumPy is numerical Python, so matrix operations and numerical calculations, we use NumPy module. And Matplotlib for graphing purpose, graphical, I mean graphs and 2D graphs, 3D graphs, histograms, bar charts, pie charts, any kind of a graph, any kind of a data visualization application, we use Matplotlib. And Pandas is actually a library available for data pre-processing and data sets management, those kind of applications. So our main focus in our this coming set of the workshops about deep learning, machine learning, image processing. So these are the set of third-party modules that we are using in with Python for our implementation, neural network, machine learning, image processing, those kind of applications. So what's the part, or what's the usage of NumPy, Matplotlib, and Pandas? So these are the helping libraries for us. Now we will heavily depend on NumPy, Matplotlib, and Pandas in our implementations in throughout our course. So the main libraries are TensorFlow, Keras, OpenCV, Scikit-learn. So we use them in our implementations, but our assisting or helping libraries are NumPy, Matplotlib, and Pandas. We will use this for lots of applications in our coming implementation. So what we will do before going on to our workshops based on TensorFlow, Keras, OpenCV, or Scikit-learn, we have to learn about these OpenCV, NumPy, Matplotlib, and Pandas, these kind of helping libraries, and get to know, get familiarized with those libraries. So then it will be quite easy for us to work with TensorFlow, OpenCV, Scikit-learn for machine learning, image processing, and neural network applications. So what we are going to do now, we are going to discuss about NumPy, Matplotlib, and Pandas in brief, and get familiarized with those modules, right? And so if you want to install these libraries, these third-party libraries, so they are not coming inbuilt with Python, right? So they should be installed separate. You have to do it separately. You have to download it from the internet and install it. But don't worry, no need to do it manually. We have a very handy tool in order to do those installation. For example, we have to install TensorFlow, Keras, OpenCV, those things in our development environment manually, but no need to download it and install it manually. We have a very handy tool, as I mentioned earlier. What you can do is you can directly go to the Anaconda prompt, and in Anaconda prompt we have a command called pip. So pip simply refers to Python package installer, and then what you have to do is just provide the library that you have to install. So how to install the OpenCV library? OpenCV Python. So this is the command that you have to provide the install OpenCV library in your computer, the image processing library, right? So then you can hit enter, so it will download it from the internet and install it in your Anaconda, right? So this will take some time and it consumes data, so data charge will be applied. So when you are going to install these things, make sure that you have connected your computer to the internet, and this will take some time, so I'm not going to run these things now. Then pip install TensorFlow. Simply install the TensorFlow library in your computer, right? So you can install it like that. It will take some time, so I'm not going to install it now. And pip install Keras. So you can do it like this. Or else simply you can install everything at once like this: OpenCV -Python and space TensorFlow and TensorFlow. Be careful with the spellings, and then Keras, right? So this is how we are going to install those libraries. And the other thing is, we have lots of other libraries available that we can, any library now. We have libraries like Pillow. So how to install Pillow is just type Pillow, and we have libraries like Flask, how to install Flask, pip install Flask. So just type the library name. So it does everything for us. Like it finds the suitable library version, and it's download it from the location from the internet, and it download it to our computer and install it in Anaconda. So all the things are done for us. No need to worry about anything, right? So everything will be done automatically by this Python package installer command, right? So you have run it in the Anaconda prompt. Now you may be wondering, no need to do it. No, I mean, don't we have to install scikit-learn, NumPy, Matplotlib, and Pandas? No, the thing is, in Anaconda, as I mentioned, and Jupyter Notebook, so these are specifically designed for data science related applications, and as I mentioned, machine learning applications. So I mentioned this at the start. Therefore, what they have done is, with the installation, they have provided NumPy, Matplotlib, Pandas, and scikit-learn. So no need to install these separately, but keep that thing in mind. If you are using any other development environment like Visual Studio or PyCharm or any other development environment, Python, IDLE, so any kind of a development environment other than Jupyter Notebook, then other than Anaconda Navigator, you have to install NumPy, Matplotlib, Pandas, scikit-learn as well. But in Jupyter Notebook, those will be available inbuilt only in Jupyter Notebook, right? Only in Anaconda Navigator. Okay, so let me quickly show you where these libraries are located. So I know that you know that earlier I showed you where the inbuilt libraries are saved. So in the lib folder, right? Then what you have to do is you can go to the folder called site packages. So these site packages contain all the third-party modules installed in your computer, right? So I have lots of third-party computers, so I mean I have installed them already, but you may see only few. Since if you are a fresh user, you will see a few. So let me show you the NumPy. So if you go to the right, so somewhere NumPy will be found, NumPy, right? And Pandas will be there. Here's Pandas. TensorFlow somewhere like this. Yeah, TensorFlow, right? Scikit-learn will be available. Likewise, all the third-party modules are installed there, right? So, and the Python package installer, if you want to install a new library like Flask here, let me show you. Flask should be available somewhere here. Yes, here, right? So likewise, if we want to install something from the internet, just pip install whatever the library name, so it will install it for you, right? So in this moment, what you need to have in your computer is NumPy, Matplotlib, and Pandas and OpenCV. So OpenCV, you have download it and install, and uh, it won't available as inbuilt type, right? So what you have to do is pip install OpenCV-Python, which install the OpenCV in your computer and keep it ready. So now we are going to discuss about the basics of NumPy, Matplotlib, and Pandas. So they will be available inbuilt. Install OpenCV, and we will discuss about those 4 libraries in brief in the next set of videos. So thank you very much.